Thanks. All right. Looks like a nice group out here. All right. So yeah, that is a true story. That I found out they were sponsoring, and I was like, "Hey, can I meet some of my coworkers?" And they were like, "No, you're it." So they FedExed all that stuff out, and I set up. I am going to be talking about cloud-native workloads, and this is an introduction, just as the official title said. I know some of y'all want to break into Kubernetes and hack the planet. We're kind of going in sort of a reverse evolution with the talks. We've got, the real deep stuff on particular technologies. Ryan, who's probably drinking at this point, who caught Ryan's talk right before lunch? Okay, cool. It was a really good talk. Watch it once the recordings are out. It was interesting because I was sitting there and I was like, oh man, I forgot to mention that, and then realized actually that we fit together kind of like a nice game of Tetris. So he's very practical and I'm very theoretical, and this is an introduction to some of the stuff that you're going to see out there, or some of the stuff, if you're more experienced, that you're going to go back home and teach to people. So borrow whatever you want. Here's me. This was a talk I was giving at Puppet conference. Had a colleague presenting at the same exact time slot, and I told her I was going to get confetti cannons so I was better, and then I actually did. Took a while for me to clean that up. I've been in operations forever, all the way through the first .com boom, number of different startups, but then also big companies like PlayStation. I'm in the credits of over 20 video games. That's kind of fun. And then I spent about 7 years at Puppet Labs, doing professional services there, and that's where I really got the DevOps feeling. So I'm a real enthusiast for that. I like the idea of DevSecOps. Some people think it's a silly buzzword. I think it could be a nice way to look at things. Now I'm a cloud security specialist. I do work for Wiz. I used to work for Palo Alto Networks. Funny story, true story. Ryan and I used to both work at Palo Alto Networks, and now I'm at Wiz. He's at Orca, so maybe we'll arm wrestle later. My free time is spent. I like to go running, clone RFID tags, and I really do think technology should affect positive social change. All right, let's get started. Just going to run through what the cloud service providers call the shared responsibility model really quickly. And this is something to keep in mind as you're securing the cloud, is that the cloud service providers, they draw a very clear line between what they'll do and what you do. And they consider their responsibility to just be providing the hardware and the services, keep the credit card machine swiping, and that's where they draw the line. It's up to you to configure things correctly and then to run safe workloads out there. So when you hear shared responsibility model, that's really all they're talking about, is this dividing line right here. Like anything new, this comes with acronyms. So here are a few that you're going to see. CSPM, people are going to say that without explaining it. It is Cloud Security Posture Management. This is really how you configure your cloud. You're also going to see CIEM, which is supposed to be pronounced KIM, because a SIM is a thing. Cloud Identity and Entitlement Management. This is an entire focus on more than just IAM, to say RBAC and IAM and permissions in the cloud are all a bit new, and we need to look at them in a new way. And so there are entire companies out there that are selling products that do this, that calculate effective permissions, stuff like that. And this is very important in the cloud. Cloud Workload Protection Platforms, CWPP. You're going to hear that acronym as well. And that's really just what you run on there, just the workloads. So easy enough. CSPM is cloud security. The W in CWPP is for workloads. Easy enough to keep those straight, hopefully. Gartner, because they love to, invented another acronym, Cloud Native Application Protection Platform, which wraps up all this stuff into one, along with a few other things like web application firewalls and stuff. I don't expect you to see this one so much. All right. So I use the term cloud native, and it's actually a real philosophy and a real term, and it doesn't just mean lift and shift. You'll hear people, joking that the cloud is just somebody else's servers. At the start, yeah, sure, most of our journeys, especially rushed by lockdown, were to just get our servers out of the racks and into the cloud and save some money, make life easier. A cloud native technology, though, has a bit of a different philosophy, particularly that they tend to be disposable workloads, or that you need to be able to think of your servers and services as disposable. Not your data, but the services. Also, this is my DevOps, of course, is everything is automated and codified. So no more logging in, clicking things, no more 2 a.m. patch management. Everybody goes and logs in and updates things, and we have a reboot. Everything should be automated. That's nirvana, but that's the cloud native way. And then all sorts of stuff as a service. Databases, storage, applications. That's a very cloud native sort of thing to do. That's slanted there. It's not the best place to put my coffee. All right. So here are some things you need to think about if you're going to defend your disposable workloads. And what I'll start out with is that you should look up cattle versus pets if you haven't heard of it. It's pretty old. You may have heard about it already. The very basic oversimplification is that we have different types of animals. Also, you're going to get tired of the stock animal photos, icons, but spoiler. Is that we used to have servers that we loved and squeezed and called George. And if something happened to them, we had to log in and fix it. We had to undo some damage. We had to patch some things. And those are your pets. In a cloud native world where everything is disposable, automated, codified, you can actually treat things like cattle, which I guess some people take offense. But the idea is that if the cow gets sick, you just send it off to slaughter and you get a new one. And once you've got things automated and codified, it's really easy to do that. To say, hey, I've got this system, it's got the log4shell problem on it, and everything is automated. What I'm going to do is I'm going to change the definition of how it should be, and then just redeploy it. So that's a very cloud native spirit. In that sort of style, it means that EDR or runtime defense serves slightly different purpose, which is rather than EDR needing to have the R in it for a response, the EDR just really says enough to say, hey, this server needs to get killed and redeployed without the vulnerability. Like Ryan was saying, both are essential for different types of workloads. We do all still have some pets in different places. So you may still need EDR on some high quality targets. Here's the fun one, is codifying all of your infrastructure and your configs and stuff like that means you can put them in version control and you can put them in development pipelines. I'll go a little more into that later. And as we do things like Docker, as we use things like Terraform, developers are making choices. They've already been making choices about which packages and which versions they need. They're now making choices about the machine size or the permissions on different workloads. So we have to get security into that development pipeline. And I'll talk later a little bit more, but the easiest way is to start by putting it into your continuous delivery, your CI/CD. All right. Here's the cattle. I'm not going to discuss the innards of Docker or containers or Kubernetes, so sorry, Princeton. You moved up from the back, too. Thank you. So this is the cattle feeling here, is that cattle, because we're going to kill them and recreate them, they're small, they do a thing. Here I've just got sort of an example of somebody connects into a front-end container. This tells their browser what to do. It interacts with other small services, microservices, to get things that it needs done. I told you that animals, you're gonna see these a lot. A microservice architecture is very interesting. They tend to be run entirely on APIs, and each of these exposes some related APIs. So for instance, session management, log in and out, or your cart, payment metrics, all this stuff. These are nice blocks, and in a microservices environment, developers love it because they can move fast, because the agreement is, as long as I don't change the way my API works, everyone else can use it. So I can go crazy inside the cow and do whatever I want, as long as I still expose the same API. The networking gets kind of opaque. So if you're used to scanning or doing network attack, inside a cluster, you don't see that network. It gets really interesting when shops are used to just running tools that do network-based scans, because they'll come back to you and they'll say, this service has these vulnerabilities. And they can't tell you, actually, it's in here or in there. So you'll have to adjust to that a little bit. On the flip side, that does make it way easier to defend against abuse of those APIs. If this container only does 3 things and it only takes certain inputs that I know about, I can then make an allow list to protect it. So we can actually bring the security down tighter, protect against lateral movement inside the cluster, instead of just worrying about from the outside. Containers are made of base images and then layers on top of them. A good way to get started with security is to certify certain base images as the ones that developers can use. And then from there, they can layer things on. And then if there's a vulnerability, you check the base layer. If it's not there, now you know who to talk to about which layer brought it in. Like I said, I'm not going to go into the nuts and bolts so much, but these are the things to look for. The really fun one for me, and talking to people, I'm actually finding people who are going from the lift and shift directly to serverless, because containers are sort of a middle step of breaking everything apart so that you can develop it as long as it keeps behaving the same. I've disassembled the cow. That's not actually a bunch of United States states. And each one does its own thing. So I had session was a container, handles a bunch of API endpoints that are related. Serverless is just enough code to do a single API endpoint, log in, log out, track you for the surveillance state. And another thing that you're going to notice, so be prepared, is not everything's going over an IP network anymore. Once you're in the cloud, it's possible for a serverless function, or indeed a container, to talk to other services without going over a network. So you're going to need to get comfortable with the fact that maybe an app uploads a file, it gets converted to a PNG without anything ever running over a network, and getting dumped into storage. See, animals again, it's a silo. Getting dumped into storage without ever traversing a network. So some interesting situations there. The allow lists, though, are so simple, it's crazy. And what's cool is, more about this later, is that the developers can tell you, this serverless function only has this endpoint. It only takes 4 arguments. These 2 are strings, this one's an integer, and the other one is a dictionary. And so it's really easy to protect these when you cooperate with the developers, and they just say, here's a definition of what it does. You use codified automated systems to take that policy and then enforce it. The thing that's going to get crazy is dependencies. So pretty much what I'll say about that is that since we're all reusing code, it's important to, number one, know what the dependencies are, but number two, assemble your code and test that as well. So not just testing what the intention of the code is, but actually assemble it and look at what dependencies got pulled in, because you don't always know. And see, here's where I kind of ran out of animals, but these are the ones that are built into Keynote, and I was really determined to use them. I think the octopus is okay for the load balancer, and secret squirrel, I'm okay with that one. So hopefully you all agree. Containers, serverless, these things are meant to be disposable, so where the heck do I put the stuff that's actually persistent? If you've gone cloud native, rather than storing it on the workload, you're storing it in some sort of native service in the cloud. Or even in your hybrid cloud, they have the same concepts. This is where the CSPM, the Cloud Security Posture Management, really kicks in. So the disposable is all workload protection. Here's where it gets kind of interesting. And we've all seen a million breaches around open storage and databases. It happens. It's important to keep an eye on this stuff, and it's important to keep an eye on it in all of your environments, not just production. We've seen a few breaches now where a developer needed to test something and recreate a situation, and so they dumped the production database, put it into development, and then there was a really expensive asterisk in the IAM. You'll use cloud native load balancers, so all you have to do is configure them. And that's really the story, is that the configuration is the thing. Secret stores, these will be very important to you, is you never want a secret anywhere except for in a secret store. Then you can control where things come and go from. Ryan was talking about an exploit that used server-side request forgery to take a look at the environment in a workload. And that's a pretty accepted way to do things, so he was on the cutting edge there to attack it. But really, secrets should all stay in a dedicated store. And I put firewalls on here just because it's like another thing that you configure and codify. And if you're doing infrastructure as code, if your developers are telling you what they expect their API endpoints to do, it's really easy to just automatically configure a firewall. And just when you push your code, you push your firewall. And the developers tell you, I'm running this port right here, it's running this protocol. And you just tell the firewall, yep, port protocol. If they change what they're running, they change the definition. Questions so far? Okay. Clear to send. All right. Let's talk a little bit about infrastructure as code. It's been around. You can do it for your lift and shift. But where it really gets cool is in cloud native. And as you go cloud native, I think it's really important to make sure that you are doing infrastructure as code, that you aren't doing click ops, as they call it. It's all automated, and it's all in code, so you have better control over it. Developers have the advantage of if something breaks or if there's a security vulnerability that's introduced into the environment, you say, hey, what did you do? And they just go git diff, and they say, here's exactly what I did. We should be able to do that with infrastructure, and as you go cloud native, you should insist on it, because then you can just do a diff. You can say, hey, the firewall is doing this weird thing, and you can do a diff, and you can say, you forgot to change what you told me to do for the firewall, because it's all in there. Different brands of this stuff. From the field, I can tell you that early adopters of AWS are using AWS's CloudFormation. ARM is an Azure one. Don't see that a whole lot unless people think they're all in on Azure. Terraform just gets bigger and bigger because it's cross-platform, and it's also not just cloud stuff. Anything you can teach it to configure, you can do. Plus, it's cloud agnostic. So companies are increasingly they don't like to get locked in. Or if they get locked in, they like to know that they can jump ship. Here's the old school. Shout out to my old company there. Is we've all been using configuration management now for quite a few years. And it's not that much of a jump. It's just the configuration of my systems is now the configuration of my whole infrastructure. And you want to scan this stuff all over the place. Certainly, there are commercial tools. There's a lot of open source out there too. And there's a lot of open core technology out there as well. Scan this stuff all the time. And you can do it in all stages of the life cycle. So developers can just scan something from their laptop. You can do it in CI/CD, and you should definitely be doing it on running systems. Once everything's codified, once everything's in version control, drift is an incident. So it just makes life easier. You're not chasing false positives where somebody says, oh yeah, well, we have you set that up, but then we fine tune it to do something else. You can just, if you see drift, you can really just open a ticket automatically. I love automatic. All right. Shift left. Who's familiar with the term at least? All right, this will be fun then. Okay. Okay, yes, CISO knows. All right. So shift left is really based on the idea that it's easier to fix something in development before it's in production, because you get one thing wrong in your infrastructure as code, you push it to development, and maybe you aren't looking all that closely. QA, you really just care if the app runs. And then production, now you've got a really big problem. So it's similar, I'd almost say offshoot. It's inspired by the DevOps movement, where we said there's a disconnect here, and ops would like to be part of the development. This says, hey, why doesn't security help developers do stuff better at that stage? So it's called shift left because the development lifecycle is considered to be, I try some stuff, I develop some stuff, I push it to version control, I then go to dev, QA, production. Shift left is, hey, I want to get security involved as soon as possible. I see it being used as a blunt instrument a lot, and I really encourage y'all to not do that. It's similar to the early days of DevOps, where DevOps really, the dev was kind of lowercase and the ops was all screaming caps. Because as operations people, we were like, dude, our systems were fine until your lousy code got on there, right? And so, jerks that we are, we said, okay, well, we're going to get involved earlier on in this process and keep you from, ruining our day. But as we went, we got a little friendlier and started to realize that the developers had something to give to this equation as well. Automated and codified, to bring you back to that one again, we would involve them in discussions, and we would say, man, every time you guys change something, we have to figure out what the heck to change on the firewall or the WAF. And it's a real pain. And the developers were like, all right, well, walk me through your little sob story. And we'd say, okay, well, I have to go in here, I have to change this, I have to update this over here, and do. And the developers, you could hear their jaw drop and just be like, wait, why don't you write a script? Like, what the heck are you thinking? And so we started, as ops people, to adopt development tools and make our lives a lot easier. I think there's an opportunity for security here as well. And if you're on the start of your journey, you're in a really good spot. If you're not on the start of the journey, shift left. one of the really important things to do is to meet developers in their own native tools, the tools that they like to use. I've seen far too many dysfunctional organizations where they scan something, they send an Excel spreadsheet to the developers, and they say, here, you suck. And it's not right. What developers do when they're developing for their code is they'll change some things around. They might run some tests locally, but frankly, we've gotten so good at doing automated tests in the pipeline that most of them just push their code. It's a branch. It doesn't really matter. Just push it and let the robots tell me, syntax error, or lint says that this doesn't look the way that we write things in the organization. There's a chance right there to add in security as a test. It doesn't have to be in a serial. It can be in parallel. It's not going to add any time to their test runs. Now when they push code, along with its associated infrastructure, they're going to see right there in the tools that they use, hey, okay, maybe this function ran, the app is acceptable, but oops, you left this like way too open, this storage bucket is open. That's something they're used to, is pushing the code and the system says, here is the status and you'll have to fix this before you can move on to the right, so to speak. So meet them in their tools. Don't make them log into your stuff unless they're curious. Finding a champion is really important. I'm not going to go into it because there's some amazing talks on this. Particularly, I like the She Hacks Purple series. This is an important one to the function of your organization, is rather than just kicking over problems and saying, hey, you got server-side request forgery here, for instance, to use Ryan's example, is to say, here's the pattern of development that causes this. This is the sort of thing to look for. Your developers want to learn stuff. They don't want to just, change a star into, a smaller scale. And Ryan also talked about this one. You have to admit that not all vulnerabilities are the same. And you have to let developers know which ones are actually important. So you need tools that can do that. There are commercial ones, there are open source ones. What he was getting at is that if you're going to search for this sort of stuff, you want to find some tools that have a graph approach to things. Graph in terms of vectors and edges. Something that can connect the dots and say, hey, this storage bucket is wide open to the VPC it's in. And this storage bucket is wide open to the internet. So that they know what to fix, and also so that with the limited time that they have, they can say, hey, look, this one is lower priority and I really would like to skip it for now. And you can say, okay, that's cool, that's all right. Also, same thing, tools out there will offer how to remediate things. In fact, some of them will even put in a pull request for you, so that when a developer creates, particularly infrastructure as code, where they're copying and pasting examples, it'll just throw in a pull request. There's all sorts of stuff out there that'll do it. So you got to be friendly, and by borrowing tools of automation and things, we can really do better. So that's my shift left slide. There are tons of presentations on shift left, so this is really just hopefully enough survival skill for you to get back to work and figure out where you're going on your learning journey to learn more about that. Here's a cool one and very new. This is it's not the newest idea in the world, but it's coming back up again, is the idea of policy as code. So similar to how DevOps, at first was DevOps, and then we realized we could borrow some dev tools to make ops also better. There's an opportunity here as well to really cooperate. Borrow from the, I don't even remember why I put borrow from the best in there, except that I'm sure it was about developers and borrowing their tools. Here's my encouragement to you, is since we're doing infrastructure as code, since we're doing Docker files, configuration management, stuff like that, and since we're involved in all of it, we're now trusting the developers. And we are sort of developers ourselves a little bit. And the same way that a developer, when they check in their code and push it and let the robots sort it out, and it comes back and it says, hey, you got this line with more than 80 characters. And around here, we don't like code that goes beyond 80 characters, so tidy it up a little bit. And the developer says, well, there is no way to go under 80 characters. They put an end-of-line comment, and they just say, hey, ignore this. It's not valid. This is my challenge to you, and if you take anything out of this talk and out of the DevSecOps part of this, we should be able to do this. Developers should be able to put a comment at the end of a line that looks dangerous and say, it's not, and we should trust that. I know probably some people are getting really frightened, but yeah, I'm seeing a lot of shaking heads, and I think you're going to be left in the past. I think this is the only way to survive with things moving so fast. And again, test in the pipeline. So policy as code means that if I'm going to test things, I can test my defense in my pipeline as well. I can do continuous attack, I suppose would be the term. And yeah, you really just got to trust. The flip side is nice too, though, is that if a developer can tell you, hey, here's exactly the policy that I think you should have, it helps them tidy things up as well, because they have to better understand the working of their application. They can't just kind of throw it out. And they really become part of the security practice. Wow, I went really fast on time. But maybe I've got some questions from the people who are shaking their heads. Here's my summary. It is a brave new world. It's a really cool one. About a million different possibilities. I could nerd out on serverless probably forever. It is really fast and it is disposable. So get used to that. Don't name your servers. Just go with a GUID. I mean, honestly, just go with a GUID. And if you can't just go with a GUID, you're doing something wrong. Your infrastructure as code should be enough to say, these are my web servers, these are my application servers, and these are my database servers. I don't care what they're named. I just told you make some, they're connected this way, my security policy is this. Great. I get a problem, I change the one thing that's a problem, and I say rebuild it. So you have to get used to that, otherwise you're just not going to survive. You're going to become an impediment to development, and I mean, hopefully you're close to retirement age, and you can just be like, well, they'll just turn me into an architect, I'll be fine. Containers and serverless are big. Personally, if you ask me, I think containers are going to go away, and we're going to be mostly serverless. I mean, we'll never get rid of like servers, and probably never get rid of containers. But I think serverless is really where everything is going. And similar, it's an interesting anecdote, I guess, that in some what we call developing countries, but it's a bad term, they leapfrogged and have better cellular coverage than some global north countries, because they never built the infrastructure for wired telephones because it was expensive and they just weren't there. And now that they're doing telephones, they're like, well, what's with the wires? I mean, why would you even do that? And so they have better coverage than what some people consider developed countries. And I think we're going to end up in a really interesting space where we're going through all these technologies and we're adapting all this stuff, and then when Gen Z gets out there, they're going to have a very, very different opinion of how to build stuff, and I think it is going to be serverless and things as a service. I don't think they care about how things work. I think they just care that they do work and serve a purpose. My last bit here is to shift left, and you've got to trust those developers. And my call to action is to just start small, pick one thing, maybe scanning stuff in CI/CD. That's a really good place to start. Gets the developers comfortable. They know it's not going to break anything. Find champions in the development organization. You're going to learn new things. I mean, that's why we're all here, is to learn new things. There is so much fun stuff out there. Learn enough. Ops people, security people, we all know you just learn enough that you know where to look it up. So relax. You're going to learn new things, but they'll probably be just on the surface to start. Rely on the developers to go deeper, and go get them. Questions? Yes. Okay.
You said at the end trust.
Yep.
I would say trust but verify, because the way code gets reused,
Yeah.
dropped into place and whatnot,
Uh-huh.
you're setting up a situation just because code is trusted
Mm.
by one. There's actually a vulnerability in it, but if you switch to the paradigm of trust but verify,
Okay.
you're a little bit safer.
So the question was, why are developers so stupid and sloppy? All right. Well, okay. All right. Interesting crowd. What type of an organization do you work at?
One of those.
Okay. One where they're lazy and sloppy
Very good.
and stupid. Okay. Here's what I would say. Here's what I would say is, and I really, really loved Jen Easterly's talk this morning, where she was talking about being vulnerable and talking about patching vulnerabilities and how the two kind of seem at odds. And if that's your view, if that's your attitude, then the pragmatic approach is to start by implementing checks in CI/CD. And if your organization is one where security rules with an iron fist, you'll be just fine. Scanning in CI/CD, you'll be able to completely stop all progress, completely cease business functions, and that's how you do it. And CI/CD is the best place to do it, because at least by then, the risk accepted doesn't get check marked on something. But I really don't like that attitude. No, that's fine. It's valid. Yes, I do appreciate the perspective. I think we all need to kind of grow up.
Or you need to make sure you factor in checks and balances instead of just leaping forward. So I understand
Mm-hmm.
screw up phrase, but
Yeah.
also grow up with a little bit of checks and balances.
Yes. Grow up with, well, yeah, have fun, but with adult supervision.
Pretty much.
Yeah. All right. Okay. All right. I guess I just have more friends who are developers. What else? What else is on your minds? Princeton.
Why do you think that containers are going out of style? It seems relatively easy to configure an EC2 instance or
Mm-hmm.
a Docker container as opposed to serverless, where you have to
Uh-huh.
write functions that match other functions and such.
Yeah. I think it's going to go the way of the dodo because it's so much easier to develop. And I think it's also so much easier to figure out where your compute power is going to come from. If I can go a little cyberpunk, which I guess I'm allowed to do, to go a little cyberpunk, I think probably I first read it from Bruce Sterling, but it was probably somebody else who came up with it. Which not a ding on Bruce Sterling. It's just I only read the big guys. Is if we can adopt serverless, and if we know which serverless functions need to persist information and which don't, we don't have to care where the computing is happening. And so the idea of Bruce Sterling idea was the idea of a substrate, there's compute power everywhere. I've got 8 different devices here. I've got my watch, which is doing basically nothing. Why not use its extra cycles to run some other function? So if my phone wants to do a whole bunch of stuff, and it has enough capacity, great. if it wants to do it faster, why not hand a function to something else and just say, hey, if the watch has extra time, I want you to help me crack hashes or whatever. So I think it's going to be driven by developers. I think the fact that you can work so fast is going to be the thing. And for me, I love that protection of a serverless function is dead simple. It is a single API endpoint. It does one thing. I know what inputs I accept, and I know what outputs I should expect. So that's why I think that. And I've talked with a few customers and friends and sort of convinced them of it, but I'm not all that convincing all the time. What else?
Do you think that there's a fundamental dichotomy that exists just in between security and developers, and that there's a hump to overcome there in trusting them? Because develop, like you said, developers code, their goal is to get code out the doors.
Yeah.
And so they have more of a reason to put sec ignore
Yeah.
at the end of
Yeah.
stopping them from meeting their deadline.
Yeah. The question is about sort of the hump between security and developers.
The goal is to protect the organization.
Yeah, that we have totally different goals. We seem to have totally different goals, and I agree. I think we'll do it. I mean, we've done DevOps. There are certainly organizations that can't, but I think we can do it. I think. See, I'm into the trust again, which is that I think that informed enough and knowing that their tools will catch all these things, it's the first one's going to get caught, and then the ignore is the fix. It's that workflow of I did my code, I pushed it up, it said there are more than 80 characters, and I said I can't avoid that. There are peers reviewing it, there's security reviewing it, and when they see it, just like I think it'll become as obvious as to an ops person when they see ignore the 80 character line limit, and they look at it and they go, oh yeah, obviously the stacking up those variables takes 90 characters, that they'll say, okay, that's all right. And I think that as we merge more, I think a sleazebag developer like that is just not gonna survive. And they'll just keep bumping into CI/CD. They'll keep putting in pull requests that then are getting rejected by not just security, but by their peers who are like, dude, that's not cool. You're messing up somebody else's day. That's my hope. But I mean, trust but verify is a pretty. I mean, do you remember who first came up with that phrase, though? Yeah. I thought it was Tricky Dick. Yeah.
Whether you agree with them or not, the principle is sound.
I think the principle is the same. I do. I agree with you completely. I just see a more hopeful future where we're all singing around the same campfire.
Kumbaya.
Yeah, kumbaya, or DevSecOps. What else do I got out there?
I do have a question.
Yes.
When we talk about cloud configuration and when you were talking about policy and service as well, policy as code, I know that on configuration sites, like tools like BB Cloud, you can set them up so that from governance point of view, you know where the policies are getting booked.
Yeah.
So that you have the full visibility of the risks in your organization in cloud. What about in regards to workloads?
So visibility into.
Visibility to how much risk, if they are putting these comments in there and they ignore.
Very interesting. Yeah. Well, here are two things. There is an emerging. Everybody's jumping onto it. They're starting to adapt some of the old patterns of like static code analysis to look at diffs of infrastructure as code and diffs of policy as code, and to be able to assign risk to those. So different vendors are trying to do that. Couple open source tools are trying to do that, in particular the ones that have a graph of dependencies. So I think that's where the risk calculation can happen, is that I believe that's actually emerging right now. Yeah.
Do you have some examples?
Examples. Well, I can think of a couple of vendors who do it. Not mine yet. I don't think I'll name names, but there are tools out there, and they're the ones that are in the infrastructure as code scanning business, and they can rank changes. Yeah.
I think that's really awesome.
Okay. What else? We got a couple minutes. I could talk more about science fiction.
I have it's not a question, it's a comment.
Yeah.
Having been on the other side of audits, having policies as code is pretty helpful. That you can, if an auditor asks you like what's the policy, you don't just show the pictures like here's literally our policy.
Yeah.
And it makes it so much easier.
That's a fantastic comment. Yeah, that policy as code makes audits easier. We used to do that in the Puppet days too. The configuration management is to take, when an auditor says, "How do I know this is okay?" is to say, because this is the configuration that I pushed to the firewall. Thank you. All right, looks like that's it. Thanks for your time and your attention, and hit me up. I'm on that hell site with the Bluebird. Hit me up if you have any other questions. Thank you.